Let's get familiar with the requirements. The zones are selected in the first step. There are two possible choices: all zones or just the first one. Then we ask the customer to choose a tariff, the regular one or the one for students. In most of the cases, the order is done. We show a screen with a thank you message that, when closed, allows to place a new order. However, if the customer ordered a student ticket valid in all zones, there is an additional step asking about the means of transport they want to use, all of them or just the buses. So, to sum it up, there is a screen to make a choice. There is another screen to make a different choice. There is a final step from where we can start the whole flow again. And depending on the first two choices, there might be an extra step as well. To start building, we are going to need a terminal, a web browser, and a code editor. The first step is to visit the documentation of Rosmaro at rosmaro.js.org/doc. What we can find there is not only a complete documentation, but also many useful links to blog posts, utilities, and examples. We are going to use the Rosmaro Visual Editor, which is a tool that allows to draw boxes with arrows that are then turned into real, executable code. And in order to get up and running really quickly, our ticket machine wizard is going to be built on top of a Snap-DOM starter. It is an example application where all of the libraries are already configured and connected with each other. Making use of a starter is simple. We just need to clone it, then install all the dependencies, and it's ready to start. Now we might open the locally running project in the browser. In the code editor, we can see all the source files of our new project. Before we jump into the editors, let's take a look at the requirements one more time to clarify what does the home screen look like. So, the zones are selected in the first step. There are two possible choices: all zones or just the first one. So it means that there is a screen to select the zones and that there are two possible options. Cool, let's write that test for that. We won't need the example test. Our app is all about orders. So let's call the test order test.js. What's described by this test is a flow that starts with the zones screen. It means that the first step is to see the zones. The flow function comes from the test utils runner file. The test steps are going to live in their own files in the steps directory. They will be grouped by the screens they interact with. That's why we are importing zones from the test steps zones file. This file doesn't exist yet, so let's create it. The first step, called See, is actually a collection of 3 other steps verifying that the following pieces of text are visible on the screen: zones, first, and all. The assert visible function is imported from the test steps assert visibility file. If we run the tests by typing npm t in the terminal, they fail, because this flow is not implemented yet. The implementation starts in the Rosmaro Visual Editor. We load a new project. Then, we add the first node called main, which is a graph. It's going to be the main node of our application. Next, we add a leaf called zones. The code that handles the screen asking to select zones will be associated with this node. To tell Rosmero that the application should start in the Zones node, we add a node in the main graph. Connect the start entry point with it. And finally, we select the underlying node of the Zones node in the main graph to be the Zones leaf. We can now generate the code by clicking the Generate Code button. The output lands in the graph.json file. To make some space for the written part of the implementation, that is the code, we need to delete all the folders in the bindings main directory. The main index.js file may stay, because all it does is using the transparent handler, what's exactly what we need. That is a transparent node that doesn't have its own behavior. It means that when the current node of the state machine is the zones node, the main node behaves exactly like the zones node. It's simply transparent. To associate some behavior with the zones node, which is a child of the main node, we create a zones directory in the main directory. The binding, what is a Rosmar word for the behavior associated with a node, always lives in an index.js file. The binding file exports a default function of an object that gives us the dispatch function. That is the function used to send actions back to the Rosmar model. The actual binding is an object that always exposes one property called handler. Under the hood, the handler is a function of an action and context that returns some result, arrows to follow, and an updated version of the context. Fortunately, thanks to the fact that our starter uses the Rosmar binding utils package, we don't need to do all that manually. We can make use of the makeHandler function. By passing it an object with a render key, we specify how do we want to handle actions where the type property equals render. In this case, we are rendering a div with 3 children, a text node select zones, a first button, and an all button. The h function is a helper function from the snapdom virtual DOM library. It's used to create virtual DOM nodes. It's configured and exported in the src utils vdom file. The makeHandler function is exported from the src utils handler file. In order for the recently created zones index.js file to be correctly loaded and associated with the graph, we need to create a file mapping code to nodes. With the Rosmar command line utilities, it's really easy. All we need to do is type npm run Rosmar bindings generate in the terminal. As we can see, a file mapping code to nodes has been created. Running npm t shows that the tests we wrote previously pass. If we go back to the browser, we will see that instead of the button from the example application, we now see the first screen of our ticket vending machine. The only behavior currently associated with this node is reacting to the render action. That's why clicking the buttons has no effect. Dummy buttons are a good start, but our goal is a fully functional wizard. As we can see in the requirements, the next screen is about tariffs. The customer needs to pick one of 2 tariffs, the regular one or the one for students. Expressing this in the test is simple. After the step that asserts that the zones screen is visible, we add a step to select the first zone and then another one to see the tariffs screen. All the steps regarding tariffs will come from the test steps tariffs file, similarly to steps for the zones screen coming from the test steps zones file. Before we create any step for the new screen, let's extend the zones steps with two new steps. One to select all the zones and another one to select just the first zone. They are all going to use the click step from the test steps click file. To select all zones, we click the button that contains the all word. And to select just the first zone, we click the button that contains the first word. The steps tariffs.js file will be very similar to the steps zones file. Let's use it as a template. When at the tariffs screen, the customer must see the following words: tariffs, regular, and student. The implementation starts with a drawing. We will need another leaf for tariffs. Let's add it. Next, let's create a node called tariffs in the main graph. The fact that the user is supposed to land on the tariffs screen after selecting the zones is expressed with an arrow going from the zones to tariffs. The arrow is named after an event. In this case, it's selected, what means that zones have been selected. The last step before we can update the graph.json file is to specify that it's the tariffs leaf what's under the tariffs node in main. Currently, the zones node doesn't follow any arrows. Let's attach some behavior to the first button. The object which is passed as the second argument to the h function from snapDOM allows us to attach event handlers. When the button is clicked, we want it to call the dispatch function with an action that means that the user has selected the first zone. The handler is then extended in such a way that it reacts to the first action by following the selected arrow. The way following an arrow is implemented is very similar to the way rendering is implemented. Just instead of returning a virtual DOM node, it returns an object with an arrow property set to selected. Now that zones know when to follow the selected arrow, let's write some code for the tariffs. We will reuse what we already have for the zones. We just need to put select your tariff, regular, and student instead of select zones, first, and all. For now, we don't need any event handlers. That's why we are going to comment them out. We have defined new nodes and handlers, and that's why it's necessary to regenerate the automatically created bindings by running npm run rosmaro bindings generate again. Now the tests are passing. Also, as we can see in the browser, it's possible to go from the zones screen to the tariffs screen. To complete the first flow, we need to build a thank you message. There must be a way to close it, like a close button, that takes the user back to zones. The list of steps might be extended in the following way. After seeing the tariffs screen, we pick the regular tariff. Then, we see the thank you message, After closing the message, we see zones again. The only new screen here is the Thanks screen. We are going to put all the steps related to this screen in a dedicated file, similarly to how we did it for zones and tariffs. To express such a flow in the graph, we will need a new leaf, Thanks. Then, we add it to the main graph. It's important not to forget about selecting the underlying node. Afterwards, we draw an arrow from tariffs to Thanks and call it Selected. Because we want the user to be able to go back to the beginning, we connect Thanks and zones with a close arrow. It means that when the user closes the thank you message, they land on the zones screen. In order to be able to test what happens after a tariff is selected, we need to implement test steps for that. So, to pick the regular tariff means to click the regular button. Similarly, the student tariff is selected by clicking the student button. The thanks screen is supposed to render a thank you message and a close button. Closing this screen means clicking the close button. Good. It's time to jump into the code. The tariffs screen is lacking event handlers. Now we already know that we want to follow the selected arrow when the regular button is clicked. The thank you step simply displays a message that allows to click a button that will follow the close arrow. Just to make sure we didn't make any mistakes, let's run the tests. Yay, all green. Now we can go through the whole flow, from zones to tariffs, from tariffs to thanks, and from thanks back to zones. The minimal version of the first flow is ready. Let's see if it works when, instead of selecting the first zone, the user selects all zones. Unfortunately, it doesn't work yet. It fails because there is no event listener assigned to the button that's supposed to select all zones. Let's fix that. Clicking this button dispatches an action type all. Consuming this action follows the selected arrow. Now, both of our tests are passing. We can try it out in the browser as well. Another similar flow we test is a student ticket for the first zone. As we can see, it doesn't work neither. It's because there is no event handler to select the student tariff. We are going to fix it in a very similar way, by dispatching and then reacting to an action. That action makes the node follow the selected arrow. Tests are passing, and we can see it in the browser as well. It's time to handle the most challenging flow. As we can see in the requirements, depending on what did the customer select on the first two screens, there might be an extra screen before we go to the thank you message. This kind of situation would normally be programmed with some sort of Boolean-based logic, like an if expression inspecting the data left by the previous screens. But modeling the business logic with Boolean values may quickly turn into error-prone hacking with ifs. Fortunately, the automata-based programming paradigm gives us a lot cleaner, easy to understand solution. We're simply going to draw multiple paths in the graph. To draw paths dependent on decisions made when in the zones and tariffs screens, we need to make arrows they follow a bit more detailed. So, instead of the zones node following just one selected arrow, we want it to follow either the first or the all arrow. This change needs to be reflected in the handler as well. When reacting to the first action, it should follow the first arrow. Similarly, when reacting to the all action, it should follow the all arrow. To make sure we didn't break anything, we might want to run the tests. Everything looks fine, so let's move to the tariffs node. Here we also wanted the arrows to give us a little bit more information. That's why we are going to follow either the student arrow or the regular arrow and not just the selected arrow. In the same way we've just done in the handler of the zones node, here we also want to update the way the node reacts to actions. And again, to make sure everything works after this refactoring, let's run the tests. Alright, they are still green. We are ready to test the first flow with the extra step. It's about selecting all zones, going to the tariffs screen, selecting the student tariff, going to the screen dedicated for selecting means of transport, selecting all means of transport, seeing the thanks screen, closing the thanks screen, and finally seeing the zones again. The steps related to means of transport will live in their own file. No surprises there. We're expecting the screen to contain a message describing what needs to be done and two buttons to select either all means of transport or just buses. The graph needs to be extended with a new node, means of transport. The first step is to add a leaf. Then we add it to the main graph. This screen is supposed to be displayed between tariffs and thanks when it's a student ticket. Let's place it there. It means that the student arrow doesn't go directly to thanks. Instead, it goes to the means of transport node. Only then, when the means of transport are selected, it goes to thanks. The graph is not complete yet. The requirements clearly state that this extra step appears only when we are buying a student ticket valid in all zones. It is not supposed to be displayed for a first zone only ticket. It means we need to introduce the second path in the graph a lot earlier, starting all the way from zones, not just tariffs. To do so, we are going to duplicate the tariffs node. We rename the current one to tariffs1. After that, we create another node called tariffs2. We get to tariffs2 when the user selects the first zone, and we get to tariffs1 when the user selects all zones. From tariffs2, we go to thanks, both when the customer wants a regular ticket and when they want a student ticket. Finally, we associate the tariffs2 node with the tariffs leave and means of transport node with the means of transport leave. The handler of the means of transport node is very similar to other handlers. There is just no need to make different decisions depending on the selected means of transport, and that's why we can simply follow a selected arrow. The last thing to do is to fix the tariffs nodes. Now, there are two children of the main graph that are the tariffs screen, tariffs1 and tariffs2. That's why we are going to create two symlinks to the tariffs directory called tariffs1 and tariffs2, so that the Rosmaro command line utilities know how to generate bindings for them. Speaking of bindings, it's time to refresh them by running npm run Rosmaro bindings generate. Just to verify everything is working as expected, let's run the tests. We can also see it in the browser. We select all zones, then we state that we are a student, and here it is, the screen to select means of transport. It works as expected and allows to complete the first flow. Let's add a test step for the case when we select just buses. So far, all what our application does is displaying various screens. It does it in the proper order and supports all the required paths. Was good. However, it doesn't actually place any order, and that's going to change now. We are going to assert that the order is placed as soon as the user provides all the required answers. It will be another test step. For convenience, all of the steps that are related to the order will live in a dedicated file, test steps order. The consume effect function from the Rosmaro testing library will help us make sure that the expected effect is returned. It builds a test step that allows to examine all the effect objects returned by the previous steps. It's a good start to cause an effect, even if it's incomplete. That's why for now we will just cause a very generic order effect. We are going to populate it with details later on. Because the order is supposed to be placed in various moments, like after the means of transport step, or sometimes, but not always, after the tariffs step, it deserves a dedicated node so that we can clearly express it in the graph. Let's call that new leaf order. Okay. Now we can add it to the main graph. The goal of this node is to place an order. Currently, nothing special happens when the flow is finished. Let's change that by putting the order step between the last flow step and the thanks screen. All the arrows are still the same, just instead of pointing at the thanks node, they are now pointing at the order node. Of course, we don't want to abandon the thanks node. We want the user to land on this screen as soon as the order is placed. To do that, we draw an arrow from the order node to the thanks node and we call it placed. The new graph is ready. We can now generate the code. Associating code with the newly created node starts with a new file, order index.js. What we need is a binding with a handler. So far it's nothing new, we've already done things like that. What's new is how we are going to instruct Rosmaro to actually do something when this node is entered. We are not going to just render this state like we did in the other states. This one will have an entry action. Thanks to the fact that we are using Rosmaro binding utilities here, we can simply handle the onEntry action like any other action. We want this node to immediately follow the placed arrow and cause an effect, that is, place an order. The last thing to do here for now is to import the makeHandler function from the src utils handler file. After regenerating the bindings by running npm run Rosmaro bindings generate, we can run the tests and see that the order is placed. It means that the order node is entered, returns an effect, and follows an arrow to the thanks node. But if we take a look at it in the browser, we won't see anything new. It's because the new state never renders and we are not consuming the new effect anywhere. The Rosmaro Snapdom starter we are using here combines many of the battle-tested JavaScript libraries, like Redux for state management and Redux Saga for side effects. Redux Saga is what we are going to use to handle the order effect. For the sake of the demonstration, we will simply console log a message. So instead of the example ping pong saga, we want to react to order effects. They will all be consumed by a function named placeOrder. For now, the only job of this function will be to console log a message. Let's see how it works in the browser. As soon as the order is placed, there is a message in the console. Now that we know that the order is correctly placed in one of the cases, we can update all of the remaining tests to make sure that it's also correctly placed in other cases. Our empty order effect is a good start, but it's not so useful now because it doesn't contain any order data. It cannot be consumed in any useful way. Let's make it more detailed. So instead of expecting just an order, we might be more precise and expect an order for a particular type of a ticket. The test steps need to be updated. The exported constant is not anymore a test step itself. This function will take the data we expect to find in the effect. The order step will dispatch the model context as the order data. The context is the data-related state of a Rosmaro model. That is all the state that is mostly about storing information and not driving the behavior. For every new Rosmaro model, the context is undefined. To give it an initial value, we will extend the main index.js binding. A binding is not limited to just a handler. It may also define a lens. A lens is a way to adapt the context. We will use the initial value lens from the Rosmaro binding utils package to alter the shape of the context in such a way that when it's undefined, then it becomes an empty object. Please note that the lens property is actually a function that returns a lens and not a lens itself. Let's start with the zones. Instead of just following an arrow, we want to update the context. We get the context as a property. Then, instead of returning just an arrow property, we also return a context property. This is the new, updated version of the context. In this very case, we wanted to specify the selected zones, that is, the first zone. We return a new object that is very much like the previous context object, just with the zones property set to first. Finally, we do the same thing with the all action. We read the current context and we return a new one. Because the selected tariff is also very important, a similar change needs to be introduced in the tariffs index.js file. We don't just follow arrows. We also collect the order data. Here it's all about setting the tariff property. When it comes to the means of transport handler, we might approach it in a bit different way. The selected option will be part of the dispatched action. Then, when consuming the select action, we access both the current context and the action object. Finally, the value read from the action lands in the context object. Running the test proves that all the data is collected. We might want to update the saga now so that the ordered data is visible in the browser. As you can see, all the selected options are now ready to be consumed by the saga. Unfortunately, there is a bug. The order data, once filled in, is never cleared. That's why after ordering a ticket with clearly specified means of transport, every other ticket will always have means of transport specified, even if they should not be part of it. For example, here we first order a regular ticket for the first zone and see that the data is correct. It contains exactly what it needs to contain and nothing more. Then, we also order a ticket that specifies means of transport. Finally, we run into an issue by ordering a regular ticket for the first zone. It contains one extra field we don't expect to be here, that is, means of transport. Let's write a test for such a scenario. The first part of the flow is all about placing an order that has three fields: zones, tariffs, and means of transport. The second part places a simpler order that has just zones and tariffs. We expect that the order will have just these two fields. As we can see, the test fails due to an unexpected extra field. We definitely want to somehow reset the collected order data before each order so that it is always an empty collection. To make it clear, we are going to express this step in the graph. It will be the job of another leaf, reset. We need it in the main graph. Every time the ticket machine starts, the memory of the order should be cleared. That's why, instead of going to zones directly from the start entry point, we will put the reset step between these two. Also, to clear the memory after every order, instead of going from thanks to zones, it will go to reset, which then will redirect to zones. The last step when it comes to the graph is to select the underlying node, reset. The binding of this node will look very similar to what the order node looked like at the very beginning. It will also define an entry action. Just instead of causing an effect, it will alter the context. Here, the context value is simply set to an empty object. All the tests are passing now. When running in the browser, we can see that there are no more unexpected extra fields in the order. Because the context is now cleared in an entry action, we don't need the initial value length anymore. It might be safely removed. Now, just to make sure, let's run the tests. As soon as the first version of the application is finished, we get some new requirements. It turns out that the order might sometimes fail. We are expected to add error handling and a way to let the customer try to place the order again. So far, all of our test cases cover just the happy path, when the order is placed. Now that we are introducing errors, this fact should be reflected in the tests. First, test cases are renamed to reflect that they are all describing what happens when the order is placed successfully. Then, we assume that there is some sort of a "please wait" message visible until we receive an order confirmation. This message is considered visible when the text "please wait" is on the screen. The confirmation comes to the model as an order success action. Currently, the order node doesn't render anything. Let's change it and put there a message indicating that the order is in progress. We want this node to follow the placed arrow when it gets a confirmation of a successfully placed order, that is, an order success action. Also, we don't want it to immediately follow an arrow anymore. Tests are passing. To see that in the browser, we need to update our fake saga. Now it dispatches order success after 1.5 seconds. Here's our waiting screen. Okay, the happy path is covered. It's time to handle errors. The error flow will be quite similar to the happy path visible here. That's why we can use it as a template. Instead of a success, there will be an error, and getting an error causes a transition to the error screen. From there, the order might be cancelled, what brings us back to zones. Now, let's apply the appropriate changes to the list of steps. Instead of an order success action, we feed the model with an order error action. Also, we will use the new screen steps for the error screen. First, we see the error, then we close it. After that, we make sure that no order is placed. It confirms the fact that it's been successfully cancelled. Finally, we are back to the zones. We are about to create a new set of steps for the error screen. Let's import it. Feeding the model with an error action is very similar to feeding it with any other action. It's simply a step that defines the action the model should be fed with. The error screen is going to be very much like the thanks screen. It will just have a different message and a different button. Because we also want to see and interact with these things, we can use the test steps for thanks as a template. Now that the test cases are ready, it's time to work on the graph. A new leaf will represent the error screen. In the main graph, there will be a new path that goes to this error node when there is an error on the order screen. Then, when the user clicks the cancel button, we go to the very beginning of the flow, that is to the node that clears the order and starts everything from the beginning. Let's save the graph. The error action is not supported yet. Here, we are going to make the order node follow the error arrow when it gets an error action. To build the error screen quickly, we will use the thanks as a base. We just need to change the message, the label of the button, and the followed arrow. Nothing new so far. The step that asserts that no order has been placed is a little bit more interesting. It makes sure that since the last time we consumed the effects, there has been no new effect. To benefit from the new node we've just drawn and the new code we've just written, we need to regenerate the bindings. In order to be able to easily observe the error screen in the browser, let's slightly modify the fake saga. It will randomly finish with either order success or order error. Let's try to place an order a couple of times. And here's our error screen. We are almost done. There is just one more requirement we need to meet. There must be a way to place the order again. Let's add a new expectation to the step responsible for seeing the error. From now on, try again must be visible as well. There also must be a way to click try again. Let's put all these steps together into a test flow. It's going to start like the previous case. We place an order for a simple ticket. After getting an error, we try again. Then we make sure that the order is placed again. Next, the model is fed with an order success action. After that, we see the thanks screen. And finally, we are back to the zones. This flow needs to be implemented in the graph. So instead of having just one arrow going from order to error, we also need an arrow that will let the user go from the error screen back to the order screen. Finally, let's add the try again button and make it follow the try again arrow. To see it working, let's try to land on the error screen. There's a new button we might click, and as you can see, we've just placed a new order.